Hello friends, I'm Khadijatul Afra CK, second year BSc Zoology, Sir College, Taliparamba. So today we are going to discuss about aquatic mammals and aquatic adaptations. So let's see what are these aquatic mammals and what are their specialities. Aquatic mammals. Mammals are primarily terrestrial animals. Nevertheless, some of them have wonderfully adapted for a secondary aquatic life. Their secondary aquatic adaptations are marvelous and exceedingly efficient compared to those of fishes, which are primarily aquatic creatures. Although most mammals can swim in water, only those forms which are permanently taken to life in water are considered to be aquatic mammals. Some commonest aquatic mammals are Monotremata, Ornithorhynchus, Marsupialia, Chironax, Rodentia, beavers, Artiodactyla, hippopotamus, Cetacea, whales and dolphins, Sirenia, manatees, Pinnipedia, seals and sea lions. Based on the relation of water and the degree of aquatic adaptations, aquatic mammals are grouped into two: completely aquatic mammal and semi aquatic or amphibious mammals. Completely aquatic mammals are permanently chained to water. They do not normally come to land for any purpose and are unable to shift their quarters by land. Cetaceans and sirenians are completely aquatic and they never visit land. Whereas semi-aquatic or amphibious mammals can live with equal ease in water and also on land. In fact, they are terrestrial forms which spend a considerable portion of their life in brooks, streams, rivers, and lakes for concealment, shelter, food, escape from enemies, etc. Aquatic adaptations of semi aquatic mammals are sleek and slender body, dense and soft fur, elongated snout, small earlobes, flat tails, webbed hands and feet, subcutaneous fat. On the other hand, the adaptations of completely aquatic mammals include morphological, anatomical, and physiological specializations. In general, the degree of aquatic adaptation has an inverse relation with the connection of animal with land. Perhaps the great disadvantage of all aquatic mammal is the retention of lung breathing habit. Now, let's see aquatic adaptations of completely aquatic mammals. First one, modification of body contour. Most aquatic mammals have tapering and streamlined body, which offers only least resistance in swimming. This is achieved by the elongation of skull, reduction of zygomatic arches, development of cylindrical chest, and reduction of projecting structures such as hind limbs, pinnae, scrotum, etc. Second one is integumentary modifications. It mainly include the loss of hair and skin glands and the formation of blubber. To reduce friction during swimming, the skin surface has become smooth by the loss of hair. The hair is retained in those forms which visit land occasionally. Cutaneous glands are also absent in aquatic forms since they are of no use in water. The loss of hair is compensated by a thick layer of subcutaneous fat known as blubber. Blubber serves as a heat insulator and thereby prevents the loss of body heat and maintains a constant body temperature. Also, it reduces the specific gravity of the body in water, forms a ready source of reserve energy, and acts as a shock absorber to absorb the hydraulic pressure during deep diving. Next one is locomotor adaptation. There are two major types of propulsion in aquatic vertebrates, namely oar propulsion and tail propulsion. The former is characteristics of chelonians and the latter is found in fishes, aquatic snakes and aquatic mammals. The locomotor modification include the elongation of body, reduction or loss of hind limbs, the formation of dorsal fin, tail flukes and flippers or swimming paddles, hyperdactyly, formation of extra fingers, and hyperphalange, formation of extra phalanges. Next, Skeletal modification. In fully aquatic mammals, especially in whales, the endoskeleton is made lighter by presence of oil inside the bones. The skull may have greatly elongated facial region and dorsal-ventrally flattened cranial region. This advantages for darting through water. The elongated facial region forms a snout for catching prey. In cetaceans and sirenians, the sacrum is highly reduced since hind limbs are absent. Ribs are movable and dorsally arched. This enhances the lung capacity and also increases the thoracic cavity backward for floating. Modifications in digestive system. In fully aquatic mammals, with the exception of sea cows and walruses, jaws are used only for catching prey and not for mastication. Hence, they are feeble. Since mastication is practically absent in oral cavity, the salivary gland are very much reduced. Simplified dentition, absence of mastication, and oral digestion necessitate the prolonged stay of food in stomach. Consequently, stomach in whales has become chambered and specialized for crushing and digesting food. Respiratory modification. Respiratory system of fully aquatic mammals is highly modified for life in water. External nostrils are valvular and located far back on the top of the head. The dorsal position of nostrils enables the animal to inhale atmospheric air without raising the head much above the water surface. Since the nostrils are valvular, they can be closed during underwater stay. A separate airway from internal nostril to larynx is formed by the modification of the epiglottis. Epiglottis has become elonged, tubular, and intranarial. This enables the animal to simultaneously carry out swallowing and breathing. Some whales can remain underwater for more than 30 minutes. This prolonged underwater stay is facilitated by the modification of lungs, high concentration of myoglobin in muscles, and storage of large volume of oxygen in rete mirabile. Lungs are large, highly elastic, and non-lobular with high storage capacity. This enables the taking in and storage of large quantities of air for underwater stay. In fully aquatic mammals, diaphragm is oblique, and this makes the thoracic cavity sufficiently large for the maximum expansion of lungs. Modification of sense organs. For underwater vision, eyes are considerably modified in fully aquatic mammals. They are relatively smaller in size. Cornea is flat and lens is reduced. Nictitating membrane, lacrimal gland, and lacrimal ducts are absent. During underwater stay, eyes are protected by a fatty secretion from the Hardarian glands. In whales and other fully aquatic mammals, external auditory opening is small. The auditory canal is filled with a secretion and the whole acoustic system is considerably reduced. From each tympanic cavity arises a pneumatic extension which makes it swallow off the opposite side. These extensions contains an emulsion called foam, which is formed of mucus, fat, and gas. During their underwater stay, whales avoid the accumulation and bubbling of nitrogen in blood and escape from diverse paralysis by the habitual spout or blow. This involves the forceful expulsion of nitrogen charged foam through their nostrils. Reproductive modifications. In whales, testes are intra-abdominal in position and scrotal sacs are absent. So, testes never descend to a post-abdominal position and this causes no resistance in swimming. The period of gestation is considerably long so that young ones will be musk grown and nearly one third of mother size when born. The aquatic adaptations of mammals seem to fall under three categories, namely neoformations, degenerations, and modifications. Neoformations include the development of tail fluke, dorsal fin, baleen plates, form duct, Hadarian gland, etc. Regenerations are the loss of ancestral structures like loss of hair, hind limbs, fingernails, pinnae, cutaneous glands, lacrimal ducts, nictitating membrane, scrotum, etc. Modifications are the specialization of existing structures like streamlined body, dorsal backwardly placed and valvular nostrils, blubbers, rete mirabile, highly oblique elongated diaphragm, flippers, simple bilobed liver, non-lobular lungs, internarial tubular and elongated epiglottis, chambered stomach, elongation of skull, hyperdactyly, hyperphalange, backward position of nostrils, reduce the sternum shortening and fusion of cervical vertebrae, etc. are the examples. I hope all are now familiar with aquatic mammals and aquatic adaptations. Thank you.